So next up, with the National Oceanic and Atmospheric Administration, if you would, please state your name and position for the record.
I will as soon as I can figure out how to press slideshow here.
Down in the bottom.
No, there we go.
Yep.
Found it. My name is Stephen Brown, and I am a research chemist with the National Oceanic and Atmospheric Administration in Boulder, Colorado. I was asked to come here today just to give a brief overview of some work that we did recently in the area around Erie, and the reason for or my presentation here is that some of the research that we did at this study is likely to be relevant to some of the questions that this group is considering with respect to air quality issues related to oil and gas development. So this was a 2011 study, and I'll contrast what we do in this kind of a study with what the previous speaker talked about, because what an organization like Colorado Department of Health will do is a lot of long-term monitoring. And NOAA, we're largely a research organization, so we are not, at least the division of NOAA that I work in, is not as closely related to long-term monitoring, but we do a lot of work that is related to very specific process-level studies. So we will go out into the field for a period of time. We will bring as much instrumentation as we can to bear on a particular problem. And we will learn as much as we can about very specific issues related to things like air quality. So what you see here is a study that we undertook last year, about this time last year. It was approximately a one-month study during February and March. And I've actually given you the technical name of the study here, which is not something that I expect most people in this room to take away or understand. It's just to point out that our real goal in doing a study like this was to understand some very specific issues related to air quality that are not necessarily related to oil and gas emissions. Okay, so we were here. This was actually some science goals I pulled off of a meeting that we had post-study. I just put this up here in order to demonstrate that what we really went out to understand were some issues that are quite specific to the cycling of nitrogen oxide pollutants, their interactions with other common sources like road salt and perhaps sea salt that's transported into this area, and to understand a number of sort of process-level chemistry kind of things. When we were finished with that sort of analysis and trying to understand those issues, we did recognize that there were a couple of things that were also likely to come out of the study that we had done, and these were related to two issues, really, namely the Denver brown cloud. That's a well-known aerosol haze phenomenon that occurs in this area in the wintertime. And also, we did have a number of measurements that were relevant to specifically VOC emissions from the oil and gas industry. So I will tell you a little bit about that aspect of the study, even though it really wasn't the main focus of what we were trying to do. So I put a slide like this up only because it shows you that when we go to do a study like this, we bring a lot of very detailed measurements. So we go well beyond the kind of things that people think about when they do routine monitoring. I just put some red boxes around the things that are probably relevant to this audience. So the top box shows you that we did some very detailed measurements of nitrogen oxides. Speciated nitrogen oxides, you see a whole list of them there, and we did a whole series of measurements of VOCs. And if you look at the way in which we did this in this very detailed manner. So we were working at the tower site, which is just a few miles to the east of here, as the previous speaker mentioned. And at that tower site, there's an elevator on the outside of the tower. We can put all this very detailed instrumentation. We can run vertical profiles up and down the tower, so we learn a lot about not just the chemical composition of the air in Erie, we also learn a lot about the meteorology and how those pollutants are distributed. It's a very detailed kind of effort. We had a number of instruments that were not located on the tower itself, that could not be raised and lowered vertically. And again, this is a very detailed set of instruments, and I've outlined just the ones that are probably of interest to this group, which were mostly VOC-type measurements. And this is just a picture of what that ground site looked like. Again, this is the Erie site. This just shows you when we have all of the instrument containers and vans parked there, that we have a lot of equipment on site available for this kind of a study. Now, I realize this is also a lot of detail for this audience. My main point in pulling some of the scientific results out of the discussions that we had after this study was just to show you something about the pollutant levels that you deal with out here in Erie. Okay? So if you just look at the slide over on the far right-hand side here, which is showing average levels of nitrogen oxides through about a 250-meter column at that site in the middle of winter, what you see is levels around 10 parts per billion. That tells you you are sitting in an urban area that's really quite polluted in the middle of winter. And that's probably a signature more of an urban source than of oil and gas development, but certainly it tells you you're dealing with a fairly polluted urban area. I'll probably skip through this one. One thing we can do with these data is look as a function of height on a tower, for example, to try to understand where the source regions are for these sorts of pollutants. So here's the data for the nitrogen oxides displayed on polar plots that tell you kind of where those nitrogen oxides are coming from. And one thing you see in this kind of data is that particularly in the nighttime data, which are the first three wind roses that you see there, where north is at the top of those plots, you see a very distinct lobe with hot colors that's pointing south at the Denver urban area. That's telling you there's a lot of nitrogen oxide pollution that's coming into the area around Erie. That's probably being transported from the very large emission source represented by the city of Denver. I'm going to move on to a description of some of the VOC measurements that we made. And there were quite a lot of instruments here. I'll just go through a quick description of what those are. So this was a very detailed set of measurements made by gas chromatograph type instruments. That's going to report something like 50 different individual compounds with a resolution of about a half an hour. That's going to be, those measurements were located where you see this green arrow that says VOC inlet at 8 meters, and in that trailer that's underneath that smaller tower. And then there were some higher time resolution measurements made by mass spectrometric type instruments that will report data much more rapidly, but report fewer compounds. So less data in terms of the number of compounds, but better time resolution. And then on top of that, we had some discrete samples that were measured in cans. So sample the air into a can, take it to the lab, and analyze it later. Those are the sorts of things you do every once in a while for comparison with some of the other measurements. Those occurred at 20 meters on the main tower. This just shows you how those sorts of measurements compare and gives you a sense for what the VOC levels are like at the BAO site near Erie. Okay, what you see here is benzene, and I know that's one of the VOCs that's of interest when people think about air toxics or potential impacts from oil and gas emissions. What you see in this area are maximum concentrations of 1 to 2 parts per billion. To put that in context, that is a high level for an urban area, but I would say not an extreme level for an urban area. And you can see about a month's worth of data showing the variability that you see in a compound like that, which is mostly due to meteorology. The other thing you see on this slide is that the different measurements of benzene by several different techniques correlate very well with each other and broadly agree, although any discrepancies that you do see in a plot like this are due to instrumental issues that really are the heart of what we work on in terms of trying to do things with very high analytical accuracy at our laboratories. This gives you a little bit broader view then, not just a time series of one compound, but a sense for what are the distributions of all of the organic compounds that we were able to measure during 1 month in the winter here. And these are grouped according to several different types of compounds. So what you'll see over on the left-hand side are a series of alkanes, starting from very small compounds like ethane and moving to very large compounds like the decanes. So the leftmost compounds are going to be the compounds probably most likely associated with oil and gas kinds of activities. I'll show you how these compare to measurements from other areas, but I want you to note that the scale on the left-hand side of this group is this graph is logarithmic. So that is to say every tick mark is another power of 10. So this is, for example, for ethane there, you're seeing average levels on the order of 50 parts per million, or 50 parts per billion, and I will tell you now that's a very large number. You also see aromatic compounds. Benzene was from the last graph. That was one example of that, as shown in this graph as well. You see a whole series of other kinds of aromatic compounds that are related to benzene. These are the kinds of compounds that can come from multiple sources, and I'll show you an example of that as well. People worry about these because of they are some of them considered air toxics, and they probably have sources due to both oil and gas extraction and due to ordinary urban air pollution that we see in this area. On the far right, then, you see this group of compounds called alkenes. These compounds are typically more associated with urban emissions rather than oil and gas. This slide just shows you a little bit about the kind of a detailed look at the average diurnal variability that you see in a particular VOC. So I'm just going to draw your attention to the graph on the right. That shows the mixing ratio of propane. That's, again, one of the VOCs that should be associated with oil and gas. And this is just the average concentration of propane observed for all the days in the study. What you typically see is that at night you have very large concentrations of a compound like that. That's because the wind speeds are lower at night, so there's less dilution. The height through which these compounds are mixed at night is also considerably smaller, so that tends to concentrate things. And then during the day, when the winds come up and the mixing heights increase, concentrations tend to decrease. But again, I will say that levels on the order of 20 to 40 parts per billion, even at night, are very large levels of a compound like propane. What you can do with a set of data like this is to break it down into what the likely sources are. I don't really have time to take you through the details of an analysis like this. I'm just going to ask you to believe what I tell you about the ranking of these compounds in the graph that you see over on the right. This is done by using a tracer compound that's representative of oil and gas, another tracer compound that's representative of the urban emissions, and then ranking everything according to how well it correlates with one or the other of those tracers to try to attribute every VOC to a particular source or to multiple sources. So you see things like ethane and propane, they correlate best with the oil and gas, so they're ranked as the red bars at the top of that graph. Things like the alkenes I referred to before, a compound like acetylene at the very bottom, propene, those are going to be very characteristic of the urban emissions. Somewhere in the middle you have things like benzene, which correlate about equally with both types of tracers, meaning they probably have sources from both areas, both the urban emissions and the oil and gas. I said I would get to some comparisons of the types of concentrations that we found here compared to other areas. So what you see in the upper left-hand corner is just the distribution of all the data for propane. Okay, this is definitely a compound that comes from oil and gas. So this is, again, on a logarithmic scale. It's just plotted the number of times we measured a particular concentration times the concentration, so that distribution is sort of, in a sense, what you would see in an average if you were breathing this air, or what you would breathe if you breathe this, an average sense if you breathe this air. So the point here, again, this is a logarithmic scale, so the major check marks are factors of 10 increases. What you see is an average represented by that green bar, or I guess it's a black bar actually. It shows you the 2011 study in Erie in comparison to other urban areas where we've done field-intensive studies, Houston, Texas, Los Angeles, California, Pasadena, California. And what you can see is, and you have to keep in mind, this is a logarithmic scale. The propane is much, much larger in Erie than it is in major urban areas elsewhere. And that's a clear signature that we're impacted by the emissions from the oil and gas. You can contrast that with a compound like acetylene, which is shown in the bottom. That's what we think of as something that comes from traffic-related urban emissions. There's nothing very distinct about the distribution that we saw in Erie compared to other major urban areas like Houston or Los Angeles. So you see a very clear difference here that the source signatures, what is characteristic of the source signatures in this area. We also did some measurements from the tower that were vertically resolved, so that is to say we got them off the ground. These are mostly canister samples. So we would take the elevator up the tower, open canisters at various heights, take them back to the lab and analyze them. And this was quite a lot of work done by some of my colleagues who came from, actually from the University of New Hampshire at the time. And one of the things you can learn here, again, is just to identify some of these source regions. So there's a map that you can't see very well in the bottom graph there. All the purple splotches there are oil and gas wells. The Denver urban area is encircled by roads further to the south. The site at Erie is kind of in between those areas, right? And what you see is if you look at these oil and gas type VOCs, and you look at where they're coming from, so which wind directions are more enhanced in those VOCs compared to others, they're definitely enhanced in northerly wind directions or northeasterly wind directions coming from the area where you see the oil wells, whereas the urban type VOCs, the ethenes, the ethines, those sorts of things, they have a more even distribution, but if anything, they're somewhat more enhanced to the south, or obviously coming from the urban area. So that's another way of looking at the same set of data. And I'll probably pass on this. It's a little bit hard to explain. This just shows some of the vertical profiles of those non-methane hydrocarbons. Okay, so I'll just scroll through these and let you folks read these if you would like. The main point, I guess, of everything that I've been telling you is that we have a lot of this field-intensive data. We've done this in major urban areas all over the country. Because we happen to be located in this area, we will sometimes undertake what are effectively very small studies, like the one that I've showed you here at a site like Erie. Our main goals are process-level kinds of chemistry, but when we have data that's relevant to the oil and gas industry, of course, which is a major issue here, we're certainly willing to come and discuss some of those results and some of our findings. We do see that there's significant evidence for an impact of oil and gas in this area. It shows up primarily in the VOC data, but we also have a lot of other data related to nitrogen oxides and other types of particulate matter and ozone precursor gases that are relevant to the air quality that you would find in any urban area. And Denver's really no different from others in that respect. And with that, I'll finish.
Very good.
And you really threw a lot of stuff at us. So some of it went boing. You mentioned benzene.
It's a fraction of what we normally throw out there.
I'm sure it is. But you mentioned that the findings on benzene were due to meteorology?
All I intended to say was that the variability that you saw from one day to the next was almost certainly the result of meteorology.
Okay.
Right? The slow wind speeds or low boundary layers, low mixing heights gives you a lot of benzene and any other pollutant that's surface emitted.
Okay. And then it appeared that the findings on alkaline, was it alkalines or alkalines?
Alkenes, yeah.
Alkalines.
Mm-hmm.
They were, I won't say, were they extraordinarily high?
You mean to say alkanes?
Alkanes, thank you.
Differentiate between alkanes and alkenes. It's
Okay.
Yeah. You could use that language. I would rather simply quantify it. I believe there's a graph in the presentation that could show you by how many orders of magnitude the alkanes are enhanced here relative to other urban areas, and it's more than one order of magnitude, so more than a factor of 10.
And how did you folks point it to the gas industry?
Simply because propane is known to be emitted by those kinds of sources, and also because if you look at the distribution of sources within the Denver urban area, and you look at the distribution that we observed when the wind came from the north or the south, it does, you can assign that source, attribute that source based on a wind direction kind of analysis. So I would say the combination of proximity to the activity, the wind direction that's associated with it, and the comparison to other urban areas that lack that activity gives you a very strong indication that propane, as an example, is enhanced because of oil and gas activities here.
Okay. And then you had some graphics up there, and this one really got to me. I used to live in Southern California, and I stayed away from Pasadena because they have bad air.
Yeah, they do.
And yet, in your graphics, it appears that Erie has a worse situation than Pasadena with regard to some elements in the air.
It depends on what pollutant you want to measure. So certainly with respect to light alkanes, that is the case. So the Denver urban area, broadly speaking, is not worse than Los Angeles with respect to some of the other VOCs that I showed you. It's not worse with respect to nitrogen oxide, which I also showed you, but it is worse with respect to, for example, propane and certainly ethane and butanes and compounds like that.
And again, those are being sourced by the gas industry.
To our knowledge, that is correct.
Okay. Great presentation. Hopefully we'll be able to get a copy of that.
It's on this machine. You're welcome.
Terrific. Thanks a lot.
Okay, Dr. Brown, boy, have I got a lot for you. That was fascinating. I talked to you all day about this stuff. That was amazing.
Thank you.
Would you describe that presentation and the data you generated as discovery science or hypothesis-driven science?
It began as hypothesis-driven science on a completely different hypothesis than I described to you tonight. But in order to answer the questions that we set out to answer, we had to collect the data that I showed you, and it bore on questions that are relevant to the public debate on oil and gas extraction. So you could call it discovery science in that sense.
Do you have a control for the data that you presented? Do you have, so you are finding these high VOCs that potentially could be attributed to oil and gas operations. It seems to me that you can't make that statement unless you have an analysis of trying to measure VOCs over an oil field where there's no operations.
I believe I actually showed you the control study, which is to look in an urban area where this activity does not occur. So Los Angeles is the control.
Is there an oil field beneath Los Angeles?
Not to my knowledge, but I guess I couldn't answer that question definitively.
Right. So the question is, would these emissions be coming out anyway, basically? Does it matter that we're poking holes in the ground?
I understand your question. The best way to do a control study like that would be to go someplace where there was neither an urban area nor oil and gas extraction, but where there was oil and gas under the ground. I cannot stand here tonight and show you those data,
okay,
but I am very confident that if you were to go to remote areas where there is known to be oil and gas under the ground, but not extraction at the surface, that you would find very low levels.
Okay, very good. So oil and gas air pollutants were coming in from the northeast, basically, where most of the oil and gas operations are occurring. That is, it's coming in from other people are having oil and gas operations in their communities, and it's coming our way from the north.
Yeah, you could look at it that way. I mean, the oil and gas activity is spread over an area that extends from Erie roughly to Greeley, if I understand the map correctly,
okay,
and that's the direction in which the highest levels were found, or the wind directions associated with the highest levels of light alkanes.
Okay. You have any interest in running a study that would measure air quality in Erie prior to a drilling operation and continuing that through a period of time where there is a drilling operation? And based on your distance from that facility, you could, as you move out in a circle, something diffuses or dilutes down to the fourth power or something like that. Is that second power? I don't remember.
I couldn't give you the exact power, but yes, certainly things will dilute as a function of distance from the source, depending on the wind and other factors. Yeah.
So basically, have you had your interest sparked to do any kind of study like this or any other study?
Yeah, I mean, those sorts of studies are ongoing in a sense. We do have instruments that we have in mobile laboratories that do come back to this area from time to time. There's a study that's ongoing right now that I'm involved with in the Uinta Basin in Utah, where we're also looking at emissions from the oil and gas industry and its effect on wintertime ozone, which was alluded to earlier. So do we have interest in those sorts of studies? Yes. The type of study that you describe, I think, would have to be very carefully designed. But it's possible that something like that could be done. And it's also possible that we will have data from our efforts in Utah that bear on that question.
How much heads up do you need to set up a study like that?
It really depends on the scale. A major study like the ones that I described that occurred in Houston, Texas, or in Los Angeles were several years in the planning. A small study like the one we did in Erie was about a year in the planning, and an even smaller study could be as little as 6 months, but that's about the minimum.
Okay. Would you be able to make a wild guess as to the amount of the oil and gas indicator air pollutants are appeared to be generated in Erie versus coming into Erie from other locations?
Yeah, that's very difficult based on the data that I've seen.
You can't even make wild
Yeah,
guesses.
it would be really difficult for me to say that. I would, if I were to guess, I would say that the problem, or at least the data that I showed you, were influenced by the broader area of the entire Wattenberg field.
Okay.
The one thing I can say, I will say this about the tower, particularly, and this has to do with the meteorology kinds of questions that I alluded to. One thing that a vertically resolved study can do, that is to say, we were to make measurements at various heights on a tower of this nature, and we do have some data like this that we could perhaps even look into now. The closer you are to the ground, the more impacted you are by local sources, and the farther you are from the ground, the more impacted you are by regional sources. So one could undertake an analysis like that, even with existing data, to try to get at the question that you have asked.
Okay.
I just can't say right now
Yeah,
with
yeah,
certainty.
okay. There's another paper for you right there.
Absolutely.
You've got the data in your hand. Just keep mining it. No pun intended. Yeah, I was quite disturbed to see that Houston has 7 parts per billion of propane, and we range between 20 and 40. I was quite disturbed that Houston has better air quality than we do. Wow.
I should say for the record that with respect to most criteria pollutants, Houston does not have better air quality than
Okay.
this area. I was specifically comparing VOCs that are related to the oil and gas extraction activity, so propane's a great example. But if you were to look at ozone in this area compared to Los Angeles or Houston, this area would not be worse. It might be sort of comparable,
Okay.
maybe a little bit better, but not worse.
Okay. I think that's all I have for you right now. If Cindy or Craig or